All right, so let's suppose you have this joint PDF where f and x and y are e to the minus x minus y. This is one I talked about in class the other night. It's a very similar one. I'm sorry. I'm gonna do it this way. Well, actually, I am gonna do it that way. Good for me. Yeah, sure, whatever. Where x and y are both between 0 and infinity, or if you prefer, x is greater than. Now, it doesn't really matter. It could equal 0 just as easily. It wouldn't make any difference if it equaled 0, but obviously it cannot equal infinity. 0 elsewhere, of course. All right, cool. Now, suppose you're interested in, let's say, well, first of all, let me just do this. First of all, can we agree that this is a PDF? Well, probably. So I can do something along the lines of 0 infinity, 0 infinity. Obviously, it better be 1. So that's the first thing I'm going to look at. Just again, just reviewing that from before. When we get done later on, and we go find certain things, we should be able to basically get our same answer, but maybe easier the second way. So here's this guy, and I'm going to do the double integral of e to the negative x minus y, comma x, comma 0, comma infinity, comma y, comma 0, comma infinity. Huzzah, it's 1. Beautiful. Beautiful, son. Nice. Now, for instance, let's just say that you wanted to know, hey, what is the probability that, I don't know, let's see here. Well, it's okay. So if you think about this deal here, you've got x minus y, right? All right, negative x minus y. So obviously this is it's not this, it's this in 3 dimensions, yes? Right? It's this in 3 dimensions, right? So it kind of goes out that direction. We could look it up in 3D calc plotter. I don't think we need to do that. Now, hypothetically, what if a person said, hey, listen, x plus y needs to be less than or equal to 1. All right. And furthermore, I want to know, hey, what's the probability that happens? Ooh, that's a good question, Jay. Thank you. I appreciate that. Yeah. Interesting. So what would I do in this case, right? So when I look at that, man, I need to look at my 3D calc plotter. So let's go have a peek at that to see what's up. So calc plot 3D. There we go. Cool. Killer, dude. And a little z equals action here. Boom. And so my z equals, of course, is e to the parentheses, this is negative x minus y. Doing its thing. How exciting. And then let's just say, excuse me, let's let x plus y equal 2. And you're like, well, how am I going to put that in? I'm going to put it as an implicit surface. So I'm going to put x plus y. Oh, is it 1? I'm sorry, it's x plus y equals 1. Oh, sweet. Hot diggity. Whoa. Now, hold up, bruh. What does that look like? Now, if you look down on the xy plane, we know that y goes this way forever. We know that x goes this way forever. However, this is the line. In the plane, it is in the xy plane, this becomes a line. You with me? But if we allow it to go in 3 dimensions, it's obviously a plane. That's what we saw in the picture. But if you look at this, you're like, wait, that's cute. So what it looks like y is bounded by, well, I would say y is less than 1 minus x or something, right? And then x would go from 0 to 1, right? So you could solve this equation doing that. So for instance, let me just try that. So if I want to find this probability, I could just kind of go, all right, 0 infinity. Oh, not 0 infinity. You idiot. Pay attention to what you're doing. Freaking idiot. There you go. I'm going to do dy dx, and so I'm going to go 0. Oh, yeah, 0, sorry. This goes from 0 up to the line, right? Killer, dude. Let's try that. Now you're like, this isn't a terrible hard problem. No, this one isn't very hard. It's not very hard because of the fact that everything's nice and linear and purty. So, in a perfect world, everything would be linear, and you'd be like, oh, how exciting for us. Now, I need to do dy first based on how I solved. I could just easily have solved the other way, but I didn't because I'm a loser. Huzzah! What did I mess up now? Syntax. What did I do? Oops. Done. Oops. Let's get a little approximation there, baby. 26%. How about them apples? That's cool. Nice. Now, in reality, what you did there is you found the sum, probably that the sum was less than 1. All right. Well, what if I just told you, listen, I'm just going to let z equal x plus y. And that's what I want. And what I really want to find is the probability that z is less than 1. Okay? Now, obviously not z squared, just a different z. This is different, just a different variable. Does that make sense? And it would be cool if I could, instead of having to do a double integral, I could just let z go from, in this case, 0 up to up to 1, because of course the smallest the sum could be would be 0 plus 0 would be 0, and then up to a maximum of 1, and that might be easier. Okay, but to do this, I'm going to have to make a couple substitutions. So let me suggest to you that we let u equal, so we need two variables. We need a dummy variable, and we need one we're going to keep. So let me just suggest that we do this one here. Okay. Now, here's the trick, friends. There are a variety of ways to do this one. This is one I've taken from another source of mine. I'll be quite blunt with you. I am not very clever with coming up with these. It's just never been my thing. Obviously, because I've never really done it a lot. Does that make sense? So once in a while, I'll be working on something that I just, thank God I missed out on. Something from the mid to late 80s with vacuum lines going ever which way, and very early OBD1 stuff on a car. And I'm like, call my buddy, hey, Mike, a little help here. So if it's like really old or, more of the current stuff, since about 96 on, I'm your man. Some of that sketchy stuff from the late 80s, early 90s, nope, pass. Not going to work on it. So this is one of those situations where I've never, ever really had to do it. Okay, I've played the game. I can do it. If I sit down and really scratch my head for a while, I can come up with it. You're welcome. Just a little tricky. You with me? It's just a little tricky. Okay, so whenever I do this, I will suggest to you a particular substitution. I will not make you come up with your own. Okay, so that's kind of the big deal here. Now notice I want to substitute up here. You with me? I want to get rid of x and y. Well, that means I got to solve for what they are down here. Oh, cool. Now there's an easy way to do this, and there's a harder way. Of course, you can do it by hand if you're a weirdo. Well, it's not this hard. I mean, let's be quite blunt. It's just this. It's just substitution or elimination, all right? If you add, you get z plus u is equal to 2x. Am I right? So x is equal to 1/2. I'm just going to write z plus u. And if a guy were to subtract, the x's would go away, and you get z minus u is equal to 2y. You with me? So this is not that hard. I remember, when I first started teaching this stuff back then, everyone was like freaking out. It's so hard. It's not that hard, dude. Calm down. But not that bad. It's not that bad, I promise. Okay. You can also use a calculator. If you have one of these babies, you can just go F2 is the solve key, and you can just type in alpha u equals x minus y. Math, and z equals x plus y. And now I want to solve for, so comma, and then squiggly brackets, x comma y. There you go. Huzzah! There they are, my friends. And of course, they factor out as a negative for some goofy reason. Okay? Whatever. So there it is. Lovely. These are our substitutions. So remember, our function was this guy here. That's nice. So now our function is going to transform, sort of, to this guy. So e to the negative x. So it's going to be negative 1/2. Well, I'm just going to write negative 1/2 z minus 1/2 u. And then it's going to be, now remember the original function, it was minus y. So minus y am I right? Oh, how exciting for us, friends. So what you're left with is simply this. I feel like it's going to be e to the minus z, am I right? Because the u's cancel out. Hot diggity. Giggity! Hey, look, that's exactly what I wanted. Now, if you are clever, as again, if you're clever, Jay, are you clever? I do not claim to be clever. No, siree, Bob, I do not. If you are clever, you choose a dummy variable such that it cancels out with the algebra here, and you're left with just z. Okay? But we're not done. You're still going to have to integrate out because this guy right here is still a joint PDF of u and z. This right now is some f of u and z. And you're like, wait, how? There's no u. Oh, I know, friends. I know, but there is. Okay. In fact, we're actually probably we may introduce it here in just a second if we're not careful. Now, what do you mean? Well, what I mean is we need to take a look at, if you recall, we need to multiply this guy by the Jacobian. You may remember that, or you may not. So remember the Jacobian is the idea that we need to do dx, dz, dx, du. Jay, should I do u first instead of z? Because, I mean, after all, alphabetical order. Friends, it doesn't matter because we take the absolute value of it. So you knock yourself out. Whatever you do, though, make sure you do z, then u, or u, then z in the same order. Top, you idiot, top and bottom. Otherwise, you'll screw it up. In other words, if you use, damn it. If you did z, then u, you better do z, then u down here. Okay, if you don't, we got a problem. Okay, so dx, dz is going to be 1/2 up here. You with me? And then dx, du is also 1/2. So you're going to have a 1/2. And then the bottom one, you're going to have 1/2 minus 1/2. And so the Jacobian would be negative a quarter, minus a quarter. Oops, minus a quarter is negative 1/2. And of course, we're going to take the absolute value of that. And so this guy here, in fact, this guy is that is my joint distribution for z and u. Okay? How exciting for us. That's just it. That's all there is to it. Okay, now, question I shouldn't say it that way, are our domains the same? Because remember, before we let x go all the way to infinity. And what about y? Does y get to go all the way to infinity? That was true, but what about z? Okay, well, I don't know. But I do know that 0 is less than or equal to x. Well, what's x? It's 1/2 z plus u. It's 1/2 z plus u less than infinity. 1/2 is u minus z. Good night. Z minus u, sorry. Piece of crap, Surface Pro. Okay, so let's solve for these. We got a u and z somewhere, right? First, let's times everybody by 1/2. Right? Right? That's pretty cool. Nice. So I feel like, okay, when you do this, right, what do you notice here? Well, yeah, I don't know, something like this. Right? Seem about right? And so if you play the same game over here, perhaps, you're going to get something like, oops, what am I doing? Oh, my dang gum notes got lost. What's happening here? Uh, right. Wait, I messed up my notes. Oh, well, hang on, let's do this. So, okay. So, oh. And they're gone. Nope, here she comes. We crashed. Tell you what, Bill Gates and I are gonna have we're gonna go around and around. We're gonna have a little knockdown drag out. If this thing ever loses what I was doing, I'm gonna be very upset at it. Is that true? I feel like that's true, right? Excuse me. So when you look at this situation, okay, those are obviously true statements so far. So you got u as negative z is less than u is less than infinity. Sure, that makes sense. But I feel like u is less than z, right? Does that make sense? So when you really think about this, we really need to have one variable be dependent on the other variable, and then the other one be independent. Are you with me? So if you think about this right now, think about this with me. So let's say we're going to do dz to u. All right, whatever. So that means I have to find the limits for z. All right, cool. So I'm going to do u to infinity. Well, that's cool. No problem there. Whatever. And then u is bounded by here. And you're like, oh, dude, uh-oh, we're got a problem. Because what happens when you integrate now? Well, dude, you're going to be left with z's. And that's just weird. So we're not going to do that. What we need to have is, so that when we do our integral, let's say we do dz, then we're going to do, we can still do u to infinity. That's great, but this needs to be like 6 to 10 or something. In other words, it needs to be bounded by something so that everything else goes away. Does that make sense? So when we do this, let's think about how that plays out. Well, now wait. This says that u is greater than negative z. Sure. This says that u is less than positive z. That means that u is bounded between these two fellers. But what z bounded between? Well, the smallest that z could have ever been, right? Because z was, what was it, x plus y divided by 2? Well, the smallest was 0 plus 0 divided by 2 is 0. So 0 and then is less than z is less than infinity. For my money, this right here is the hardest part. It is the hardest part. It's not close. It is the hardest part. You with me? It is the hardest part. Not even close. It is just straight up the hardest part. Okay? Now, let's try this, shall we? Now, you're like, but Jay, so in order to get the marginal of z, what do I need to do? Well, I need to integrate my u's out. Does that make sense? And so my function is 1/2. Is that right? Right? That was my function, right? Right there, baby. Well, it's over here somewhere. Nice. So I'm going to... Okay, stupid computer, I just turned you on. How could you be having a fit already? I don't know. Nice. Hey, let's integrate this pig, shall we? What do you say? Now, oops, what happened there? Oops, I need to do du, Mr. Groom. Well, I do du. Yeah, there you go. Damn it. Gotta love OneNote, friends. You gotta love it. No. I'm losing patience with this piece of garbage. All right, let's try that again, friends. So I need to integrate with respect to you. So obviously the integral is negative 1/2 e to the minus z, obviously, from, oops, and times u. Oops, right? Wait, what are you doing? Not negative, positive. Sorry about that. Remember, this is all constants with respect to u, yes? It's all constants. Okay, and if you evaluate that, obviously you literally just go a half e to the minus z times z minus 1/2 e to the minus z times negative z, which obviously makes this positive. Stupid allergies. And when you add those together, you get z e to the minus z, if I'm not mistaken. That makes sense? This right here is your marginal of z. Okay, check this out. Should this guy, what should it integrate to? Or if this is a, I'm sorry, if this is a distribution, if this is a PDF, well, it really ought to integrate to a 1 over the entire distribution, right? So let's see if that's true. I don't know. I just work here. Yes! Now, friends, more importantly than that, remember what we wanted was a function that was easily integrable. Yes? We want the probability that z is less than 1. Oh, mama! Now, you're like, Jay, that was way harder, in my opinion, than just doing it the way we did before. That's right, because when we did before, the original problem, because it was such an easy problem, it was easier just to plug and chug and go. Does that make sense? If this was a harder problem, then the substitutions, the headaches, the Jacobian, all that mess would have been so much more worth it. That makes sense. Cool. All right. I'll pause you for a second while I get my some more. All right. Here's another one. This will be fun. How fun. So, suppose we have this fella here. It's a joint PDF of x and y is equal to 8xy when this is true. 0 is less than x is less than y is less than 1, 0 elsewhere. Okay? Whatever. Is that true? I don't know. Let's find out. Okay? 8xy dx dy 0y 0 1. You with me? Bam. Let's try it. So if I do that, it's a double integral, of course. X times y. Don't forget the times. You'll not be pleased with yourself. If you do, it won't work properly. X. Whoopsie daisy. Maybe if you put a comma in there, stupid. Huzzah. Yay, it works. Again, we are, I don't know if we're shocked by that. Maybe we are, maybe we aren't. I don't think I am, but maybe we are. I don't know, whatever. Oh, dang. Dang. What the Sam Hill is this mess? Yuck. Okay, so, nice. Now, let's think about this for a minute. Let's go back over and play for just a minute. So let's look at this business right here. Okay? So let's talk about this for a minute. If we're looking down at the XY plane, okay? So what we're saying is that that X is bounded by Y. Wait a minute. That's this equation right here. True dat. This is Y equals X. And typically, I would say that, if I'm doing, let's say I'm integrating here, I'd say that Y's are bounded by X. Yes? We call this the line X. But we're doing it the other way around this time. So we're saying that well, we're kind of thinking of it, we're looking at kind of the other way around. We're saying that the Y, or sorry, the X is bounded by the equation Y. So we're going from 0, this is the smallest that X can be, and we're going this direction, okay? And then we're saying that Y can go anywhere from 0 to 1, so we're over this region in here, is what we're talking about. So that's pretty cool. So if I were to graph that, what would I graph? Well, I would come in and I could do something like this. I could actually come in and we could do it a couple different ways. Y equal, well, what are you doing? Implicit surface. Boom, done. Okay, so there's that fella cutting through there, right? And then we want to do also y equals 1. Stop it. Stop it. Stop turning. I hate you. So y equals 1. Well, that's actually what I wanted exactly. Thanks, bro. And so what we're looking at, if I can see it, we're looking up here in this middle area. My little cursor is right there, if you can see it, hopefully. Okay, that's kind of what we're looking at in there. Well, that's kind of the idea. Now, let's say, now again, this is out of another textbook of mine, so I'm just going to play with this a little bit. Let's suppose we're interested in something different, and suppose our thing that we are interested in is x divided by y. You with me? That's what we're interested in. Why? I don't know. I don't know. Maybe for some reason that is something I need to keep track of. Cool. And then I need a dummy variable. And let's just suppose that my dummy variable is y. You know, it could just easily have been x in this case. In fact, if you are, what's the word I'm looking for? If you're clever, as I say, you can sometimes pick one that will cause it to be prettier, but you can do it a different way, and you get the same answer. It'll be a little grosser to get there sometimes. Okay? So again, I will do the suggestions of the transformations. You're welcome. Okay. It won't be hard. You're just going to go through the steps from here out. Nice. So if you look at it, obviously y equals z. I mean, duh. And so if you look at this, that means x is equal to w times z, right? That was easy money. So when you look at this problem here, well, there you go. So I'm going to have 8, and then x, y, done. This right here is my substitution, yes? Well, for the love of Pete, that's going to be weird because obviously, you know, you got y times z. That's different. It's not going to be the same. What do I want to say? Limits as before. So we said that 0 is less than x, is less than y, is less than 1. All right, giggity. So now we know that we can just drop the z in here, so that's cool. This is wz. Nice. And so, all right, well, that's nice. So, interesting. So, all right, when you look at this thing, what's your first thought? Well, we could divide by, we could divide by z. Now, can we divide by c? Well, yes, we can't be equal to 0, so we're good to go. So we don't have to worry about z ever equaling 0. So in this case, you're like, all right, cool, done. Sweet. And of course, you're like, oh, okay, well, there you go. So I would have to divide this by z as well. Well, yeah, yes, but it's still going to come out to be 1 because that would be at the biggest end that y could be, or z rather could be. Now, hold that thought. Just I got to check my notes here real quick. Okay, now I made a little boo-boo right here. See, I forgot to divide. So I divided the z, and so I got a 1 here, right? So 1 right there. And so because I got a 1 right there, well, obviously 1 is less than 1. You're like, tell me something I don't know, Jay. Okay, well, great. What this tells me is that now w is between 0 and 1. We already know that z is between 0 and 1 because z is just y. So that means now we're going to have a situation where, hold on to that thought just a minute. We're going 0, 1, 0, 1. Okay? Which is interesting. Now, if you recall, a while back when we did these guys, we said that if we could rewrite this if we could write the joint as a product of the two marginals, that means they're independent. I think we're going to see that momentarily. Now, if we do the Jacobian, now don't screw this up like Jay did a minute ago in his notes. That's why I had to go back and look at it. I'm like, why is this not idiot? What is dx dw? Well, it's z. Funny, Jay put a 1 there, because he's an idiot. Dx dz is w. Dy dw is nothing. and dy dz is 1. Therefore, the Jacobian is z. So I multiply by z here. Well, that means I have z cubed now. If I do dz dx or dz dw or vice versa, it won't matter. Lo and behold, it better be. Check it. It's 1. How exciting. Now, again, if I wanted to know, listen, I remember the original, we started out, we wanted to know this guy. We wanted to know that one. Cool, let's find it. So if I want the marginal with respect to w, or the marginal of w if you prefer, then I'm going to integrate the z's out. That's my job. Boom. This will be the marginal of w. And so here we go. I can't do it. It's too late. It's too late in the day, man. I can't do that. It's too hard for me. I'm going to integrate the z's out. Ta-da! 2w. 2w. And then, of course, then you could answer the question that you wanted. So, you know, whatever it is, what's the probability, for instance, that w is less than a half or something? I don't know. Let's find out. So it'd be the integral of 2w dw from 0 to a half. Done. It's that easy, friends. It's going to be w squared, 0 to a half. W squared, you clown. And if you plug a quarter in a half in there, you get a quarter. Ta-da! 25%. Piece of cake. All right, we're going to do one more. All right, so suppose you had this guy where I said, listen, f of x is equal to this guy. And you're like, wait, x and y or just x? Hold up, bro. E to the minus x over lambda. Whoa, hey, isn't that where x is bigger than 0, 0 elsewhere? Isn't that the exponential? It is the exponential function. So, well, that's pretty easy. It is. Not too hard. Now, check this out. Suppose I told you that x and y are identically, independently distributed. Identically means they have the exact same distribution. They're independent, which means when I say the probability of x and y, I'm going to be multiplying them. And so it's going to look like this. Well, they're identical. So you're going to have 1 over lambda e to the minus x over lambda times 1 over lambda e to the minus y over lambda, which means we end up with 1 over lambda square e to the minus x. Stop it, you hippie. What are you doing? There we go. Minus y all over lambda, yes? Because you're just, you know, combining like terms up there in that exponential there. Beautiful. Now check it out. It feels like x is bigger than 0. Y is bigger than 0. They're independent. They do whatever they want. I do what I want. This would be your f of x and y. Cash me outside. 0 elsewhere. Beautiful. Sweet. Now, suppose, and again, I am not saying that I would have come up with this one, but let's just say hypothetically that a guy says, listen, suppose I want to know what w is. Suppose it's x plus y. Oh, that's cool. What's your other one going to be, Jay? Hold your horses, friend. This one's going to get wild, dog. And I mean, wild. Z equals x over x plus y. Wait, what? Exactly. It's a little weird. I'm not going to lie. Not going to lie. However, if you watch this, it's actually not as bad as you think it is. So if you were to solve this, you're like, how in the Sam Hill do I solve it? Well, just watch carefully, friend. So if I do this, obviously, w is equal to x plus y, yes? So z is equal to x over w. So x is equal to wz again. You're like, wait, again? That's weird. A little, yeah. So then that means x is that. So then you get w equals wz plus y. So y equals, and then it's w minus wz. And that's what that guy's going to be, right? Of course, you could factor W out if you wanted to. Okay, cool. Awesome. Oh, you want to do Jacobian first? Well, I'm in charge, so I'm doing Jacobian. So the derivative dw with respect to w is going to be a z. With respect to z is going to be a w. Awesome. So we did w first, obviously. It's going to be 1 minus z. And this is going to be, with respect to z, it's going to be negative w. Well, that's just gross. By the way, if your Jacobian comes out 0, you screwed up. That's weird. So it's going to be negative zw minus, and then w times 1 minus z. I'm going to go ahead and FOIL that mess out there if you don't mind. Hot diggity. Negative w. There's your Jacobian, and of course, we're taking the absolute value of that, so w is what it is. So here we go. We're back up here. You're like, oh my goodness, that looks so pretty. Now you're going to make me stick in these other things? Yes. Yes, I am. So 1 over lambda squared e. I'm going to go ahead and write it over again just so we remind ourselves of where we're at. Okay. So I'm going to replace x with wz. All right. Oops, e to the minus wz minus y. Oh, Jay, that was clever. I know. I didn't come up with it, though, so don't get excited about me. I just work here, bud. I just work here. That's all I know. Check this out. Bye-bye. Oh. Oh, look, we get minus w. I wish it was positive w. No, you don't, friend. Oh, what do you mean? Bro, this thing is exponential. It's probably going to an infinity. And if it's not negative, you are screwed. And so you got x, which is wz. Wz goes from 0 to infinity. That's true dat. True dat. And y, which is w minus wz, goes from 0 to infinity as well, obviously. I included infinity because it makes me happier. Didn't include it, obviously. You'd be bounded by something on the top end. So I feel like, well, I mean, it feels like to me that, well, hold up now. This is a little strange, and so just bear with me here. Ooh. So, how do I want to approach this? Let's start with the bottom guy just for fun, shall we? Let's start with him. Okay, I guess. I mean, I feel like. So, I'm going to do wz is less than w, and then, of course, if I plus wz to infinity, I still get infinity, I feel like. Okay, that makes sense? And w can't be 0, you with me? So I can divide by 0. I can divide by it. And so if I divide by w, hold that thought a second. It's freaking me out. I'm sorry. No, yeah, wait, what? No. Okay, I'm going to pause for a second. My notes are crooked. Okay, a couple things. So my Jacobian, I found it, and I didn't bring it over here and put it where it belongs. So this right here is my distribution. Okay, it's the joint PDF. It is the distribution of w and z. If I wanted just w, then obviously I'd integrate the z out. Now, before I go any further, I'm weird. I'd like to know that this actually works out. That I get, in fact, I get 1, right? So when I double integrate this, so let's see if this is true. Let's just play. I don't know, whatever. So I divided by w down here, so I get z is less than 1. Let's see if this works. I mean, hey, who knows, right? So first, I'm gonna let what's his butt here? Lambda equal 1, just for fun. You with me? We'll come back and look at it in a minute, if you don't mind, with something other than 1 and see what happens. Okay, so just see what's up. We'll see that it works, of course, as well. So don't worry about that. So 0, I'm gonna do dz, dw. We're going to go 0, 1, 0, infinity. Let's see if this works out. I don't know. Just work here. Wait, you forgot to put your W right there. Yay, it works! Woo! And then, of course, if you want your marginal of Z, the marginal W. I want the marginal W. Let's integrate with respect to Z, right? So let's do this. So I'm just going to do just Z only. So there's your marginal with respect to Z with W only. And you're like, whoa, 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 whoa! Hold up, bro. Hold up. Then I'm interested now. Well, what would it be if it was what if I did? Oh, damn it! What's the marginal of Z then? I don't know. Let's find out. It's 1. Wait a minute. So wait a minute. Whoa, 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 whoa. Suppose I take this times this times this. What do you get? That times that is, wait for it. Well, it's this. Am I right? The only difference, of course, I didn't have my lambdas in there, okay? So then, wait, whoa. What does that say about W and Z? It says they're independent. Okay, it says they're independent. All right, let's go back and put that in just for fun. Let's just see if that makes us happy or not. I'm going to go ahead and clear that. I'm going to go with the original up here, which is the double integral one. And I'm going to go ahead and put it back in there because I know you're upset at me. I know you're mad. I'm sorry. You want to see that it works with a lambda out front. Well, I don't have a lambda, so I'm just going to do 1 divided by alpha. And I'm going to use something other than A because A has a matrix stored in it or some god-awful problem. And so that would just be weird. I'm pretty sure I don't have that for D. And so I wouldn't want to do that because people get upset and like, oh no, it's weird. I know. So here we go. I'll just use D, I guess. Oh no, it's undefined. Uh-oh. Okay, hold up. Hold the phone. Okay, well, let's do this. Let's don't do it as, let's just put in the 2. Okay, how about that? Doing it with variables in there, it might freak it out a little bit. Yay! And so you can see, I think, pretty easily that would work out. I'm not really sure what it's upset about. I might have something stored as D, or it might just not know what to do with D since D is undefined as a constant. I'm not really sure about that. But anyway, that's the game. And then, of course, you can answer questions like, hey, what's the probability that W is less than 2? I don't know. Integrate this baby 0 to 2. You're done. You with me? That's it. That's all there is to this. Okay? So that's transformations. Hope that helps. Let me know if you have any questions. Again, I will not be asking you to come up with your own transformations. It's just really not something that we do. Okay? If you run into this at all, you will see that somebody who's clever and has a PhD, and that's what they do, has come up with this, and you, if anything, are just following it, or you've seen something after the fact and you're playing the game. All right, good luck.